Hello, everyone. My name is Christina Cook. I work at the Center for High Throughput Computing, and I'll be giving this morning/afternoon presentation on an introduction to using HTCondor. And for those of you who've been around a while, a lot of this will be familiar, but I hope there's some new folks in the audience for whom this will be helpful in understanding how to actually use Condor to submit and run work. And for those who are already familiar with some of these ideas, to maybe use this presentation as a chance to think about how you explain and train new people in your own centers or campuses on how to get started. So what we're going to cover today is a very, very brief introduction to HTCondor, and then quite a bit of detail on how to submit single and multiple jobs. I'll then take a pause for questions and a little bit of stretching because this is quite a long talk. I will try to keep track of questions as we go along, but that will also be a dedicated time for questions. And then the second half of the talk will go into a few more details about how Condor actually works, about testing and troubleshooting, specific features, and automation of jobs. So that's our plan for today. We'll start with a very brief introduction to HTCondor. Again, many of you are probably familiar or already know what HTCondor is, but for completeness, we'll have a couple slides at the beginning here. And Condor, HTCondor, is a software program that schedules and runs computing tasks on computers or computing resources. So at a very abstract level, how it works is the user, probably some of you, has tasks. They're submitted to a queue on a submit point. HTCondor then schedules those tasks to run on computers, what we also call execute points. So you can see that in this diagram, the bottom half of the screen here. And this overall architecture can be implemented in different ways. So you can run HTCondor on one computer where the submit point and the execute points are all actually running on the same physical computer, perhaps distributed among multiple cores or CPUs of the computer. You can also distribute these components, a little bit as Marone was just saying, on different computers in different places. And this is the model we'll mainly have in mind today because it's the most common in research and scientific computing. So yeah, this is what we'll have in mind. Is there's some sort of submit point on one computer, and then Condor is scheduling and running tasks on execute points that are also running on different computers. So why use Condor to set up your compute resources in this way? Condor manages and runs work on your behalf, and you need this if you're sharing resources in some kind of way among users, whether that's sharing the resources of a single computer for a single user in a way that doesn't overwhelm the computer's capacity, to sharing resources on a group of computers, especially when you introduce multiple users trying to share resources across a group of computers. So these are all reasons why you'd want to use Condor. For the purposes of this tutorial, we're going to assume that someone else has set up a Condor pool for a user to use. So someone else has already kind of done the previous slides, decided to use Condor, set it up, and we're going to focus on how to actually run computational work on an existing Condor system. Okay, so the main thing we have to know to run work is how to run and submit a job. So first, what is a job? So those computing tasks I talked about in the earlier slides are what we call jobs. There's a lot of ways to think about what a job is. I like to think of it as sort of these three components of input, so the raw ingredients for some task, an executable that takes those inputs and generates an output. And so we'll need to address these components and how we submit our work to HTCondor. As a side note, that middle step, the executable, needs to be runnable from the command line without interactive input, because we're not actually running this executable ourselves. Okay, so to make things a little more concrete, we're going to use, in the example slides that follow, we'll have an example submit file, and we're using this particular job example where we say we have an executable called compare states. It takes 2 input files, data about a single state from the US and data from the whole country, and then it produces a kind of output file. And to run this program, you can see the command line invocation at the bottom there. We have the name of the program, and it just so happens that the 3 arguments given are the 2 input files and then the name of the desired output file. Okay, so this is our job we want to run. And so we need to communicate this to HTCondor. So job components on the left, HTCondor on the right. And the way we're going to do this is through a HTCondor submit file. So one quick note before we get to the actual submit file in the next slide is aspects of how you submit the job will depend on how your HTCondor pool has been created and configured. And so in this example, we're going to assume that the Condor pool in question uses HTCondor's file transfer feature, which basically means that the directory that you submit jobs from and the directory where jobs execute, so noted here is the submit dir and the execute dir, are in 2 separate locations, probably on 2 separate computers. Okay, so with that in mind, here's our submit file for our sample compare states job. So we're going to go through this line by line and kind of what each piece means. So first we have the executable. So that is both the first, the command in our command line invocation of the program, and also refers to the actual executable file. So that's the first line. And then the remaining arguments from the command line invocation go in the arguments line, as you can see here. Then we get to our inputs and our outputs. The input files will need to be transferred or copied from where the job is submitted to where it runs. So we'll list them both by name in a comma separated list in this transfer input files option. And then the default is that new files generated in the execution directory will get transferred back when the job exits, and we're just being extra specific about that by including this when to transfer output line. Then we have log, output, error. So these are all going to generate files that record information about the job, standard out, standard error, or information from Condor. Then we have resource requests telling Condor how much of a computer we need to run a particular job. So CPUs or cores, amount of memory or RAM, and amount of disk space. This is obviously a very tiny job looking at the requests here. And then finally, in order to actually generate a job, we need this queue keyword at the end of the file. And we're going to start with submitting just one job, multiple jobs coming later. Okay, so that's our submit file. It describes everything that Condor needs to know about sort of the pieces of the job that I described earlier. To submit it, I would be on a submit point and run Condor submit and the name of the submit file. That will put the job into the job queue, which I can check using Condor queue. And you can see sample commands and outputs in the black text boxes on this slide. So a little bit about Condor queue. It's going to come up several times in this talk because it's a very useful and commonly used tool when you're actually submitting jobs and working with Condor. The default, if you use Condor queue, is it will just show you your jobs, not all the jobs submitted by all the users in the queue. And they're summarized in batches in different ways. More on that later. There's options to not do that as well. You can look at specific jobs that you've submitted either by using your username, the cluster ID, or the process ID for a job. And that's, you can see that's the first half and second half of the job ID. So this example, 128 would be the cluster ID. 128.0 would be the whole job ID. So here's our first Condor queue option. If you want to see your jobs in the queue kind of line by line, not grouped together, you can use the no batch flag. And we're going to use this in the following slides because it makes it a little clearer what's happening over the life cycle of the job. Okay, so we've written our submit file. We've submitted it. It's in the queue. Now what happens? So now we'll have a couple slides talking about what happens behind the scenes once you've submitted the job. And so first, the job is idle. It's in the queue waiting to run. You can see this both in the summary at the bottom here and the I in the Condor queue output. And so nothing has really happened except the creation of the log file to track what's happening with the job. At some point, Condor finds a resource and will transfer the executable and the files listed in transfer input files. So here we have our 3 files being transferred to an execution directory that was created specifically for this job. See that here. Then the job is running. So everything now is happening in the execute directory. Standard output, standard error are being saved. Output files are being generated. Status is R, one running job. Once it completes, the standard output, standard error, and new files, including our output file, get transferred back to the submit node. And then it's over. There's nothing in the queue because the job is completed. And we have our output files here in the submit directory. So that's the life cycle, typical life cycle of most jobs. You can also see this information recorded in the log file. So all of those steps are recorded with the dates and times they happened. There's also a nice summary after a job completes of the actual resources used by a job. My tabbing is off here, but normally this is aligned, showing what you requested in terms of CPU's memory disk, how much you were allocated by Condor, and how much the job actually used. So that's another resource to kind of see what happened. And to put all that together in a diagram, here we have our 3 states. If everything runs successfully for a particular job, you run Condor submit, it goes into the queue and it's idle, then it goes to running, then it goes to this very, very transient completed state where it's leaving the queue. You normally don't see this because it's so brief, but it does sort of record that the job was completed as opposed to another state, which we will get to later. Okay, so this submit file example has a lot of the options that you often need, but can be customized a lot. So as I said at the beginning, some of the aspects of your submit file might depend on how the Condor pool you're using. So file transfer, we assumed in this example that we did need to transfer files back and forth because there was no shared file system. Maybe your system does have a shared file system. Then you would use a different option here, which should transfer files, and things would work slightly differently. Instead of having 2 separate directories, everything would just run out of a shared directory from both the submit and the execute point. And so you would see this difference in the submit file, and you wouldn't need the transfer input files line. Also good to think about resource requests. You know, often you're not using an entire computer, you're sharing it with other users. So it's important to request appropriate resources for a particular job. There may be defaults configured for your system, but that may not be the best for you. This is really a Goldilocks exercise where you don't want to request too much, just because then you're depriving yourself of resources that might otherwise be available to you. But you don't want to request too little, because will make your admins unhappy, potential other users, or your jobs will just be killed. So these are, the submit file that we gave is kind of a starting point. There are things that will need to be customized. There are tons and tons and tons of submit file options to do very specific things. We will touch on some of them as we go along, but definitely, I think there was a link to the Condor submit page in the manual, has everything. So take a look at that if you want to do something specific or talk to us and the Condor team. All right, so that was a pretty in-depth introduction of how to submit one job. And so now we're going to get to the real thing we want to do, which is submitting multiple jobs with HTCondor. And so why would we want to do this? We're assuming that most people that come to use an HTCondor system want to run many jobs. They have many data files, they have many parameter combinations or inputs they want to test, lots and lots of use cases. And you want to do that without having to run a loop that runs Condor submit many times. The Condor team will tell you that's not super efficient and actually slows down the queue. You don't want to have to create thousands of submit files. So ideally, we want to be able to submit many jobs with one submit file. Ta-da! That's something that Condor does really, really well. And so that's what we'll look at, some of those options in the coming slides. If you want to see a specific presentation about submitting multiple jobs with HTCondor, there's a video of a presentation from HTCondor Week back in May of this year that talks only about this specifically. So it has a lot of the same information, but really focusing on submitting multiple jobs. Okay, so we're again going to kind of have a sample job we're thinking about, a bit different than our compare states one. We're going to assume we have an executable called analyze, and that it reads in this input file. And we have 3 different input files that we want to run in 3 different jobs. And it's going to produce an output file with a similar number. Okay, so we want 3 jobs, 1 for each input file here. So our first step is we can change the Q1 to Q3 at the end of the submit file. So this will generate 3 jobs. So that's great. It doesn't quite do everything we need though, because there's nothing changing in the top part of the submit file. So it'll basically submit the same exact job, analyzing this first input file 3 times. So that's not quite what we want. What we're going to do is use this feature of Condor that when you submit multiple jobs, it gives them these job IDs where they all have the same cluster number. So a group of n jobs shares the same cluster number and has a unique process or proc ID from 0 to n-1. And we can use these job ID values, the cluster ID and the proc ID, in the submit file using this Condor variable notation. So this is great because the proc ID corresponds to the numbers of our input files. So we can take the components of the submit file that need to change for each job, which includes our input files, our arguments, and let's also uniquely identify our kind of error files, just because. And we can replace those with these variables so that we end up with the right result. Each job will get a differently numbered, will transfer and run differently numbered input files. Our log, output, and error will all have unique IDs based on the job ID. And so this accomplishes what we want. Great. So once we've done that, same process as before, Condor submit to submit the jobs, Condor queue to view them. If you submit multiple jobs, it will become a bit more clear that the default Condor queue output does in fact group things together, because all the jobs submitted from one submit file will be in one line, and you'll see these totals, how many are idle, how many are running in the whole batch. So You can also group jobs yourself instead of using so normally they're grouped by cluster ID. So all jobs submitted from one submit file, but you can also give them names to group across submit files if you sort of have related work. So that option is job batch name, and it will nicely display in Condor Q output. And again, if you want to see jobs line by line, not grouped together like this, the no batch option is what we need. Oops. Okay, so we're going to talk more about other ways to submit multiple jobs, but first we're going to take a detour to talk about organizing files and directories related to job submission, because once you start submitting thousands of jobs at once, you generate thousands and thousands of files at once, kind of achieving this effect here of the messy desk. So just a few notes on ways to organize. You can, when you use transfer input files, you don't need to transfer individual files. You can transfer a whole directory or contents of a directory, depending whether or not you use the slash. So you see kind of an example of what that might look like here. And this is useful if a job has several shared files that are needed by all of them. Then it's also easy to add or change the files without having to change a bunch of items in the transfer input files line. You can also use subdirectories for different, for files that are referred to in the submit file. So you can put your input files in a folder and use a path to refer to them. You can put log, error, output files into their own directory. Again, just put the path in and they'll go there. So this is super helpful because the error, log, output files can really clutter up a directory. You can just tell them where to go. Absolute paths are also fine. So this is relative to where we're submitting from. You can also use an absolute path to anywhere you have access. And finally, one organizational structure that some people really like to use is putting individual jobs each in their own directory. This is useful for jobs that have a lot of output files to keep them kind of separate. It does allow you to have the same name of the inputs and outputs for all your jobs, because only the directory name changes. A lot of different reasons this might work for someone, but the magic submit file option to make this work is initial dir, which you see here. So here we're setting for each job, the initial directory is going to be the job and process number. So we're submitting 3 jobs and they'll each be kind of submitted from these different directories. So all the paths except the executable are relative to this these submission directories. The executable is still always relative to where you actually ran Condor submit. Finally, so initial dir is one way to control where output goes, but you can also specifically, so there is an analog to transfer input files, transfer output files if you only want to transfer back specific files from a job instead of all of them. And if you use this, you can also rename files on the submit server using transfer output remaps. So in this example, we generate, there's a bunch of files generated, but we only want one of them. And then, well, one of them in the logs folder. And then we want to rename the results file when it comes back. So that's the syntax to do that. Okay, so detour over. I definitely recommend, if you're new to submitting multiple jobs, explore some of those options, because you can save yourself a lot of pain later on by having things organized from the beginning. Back to submitting multiple jobs. What we've talked about so far is this sort of QN and then using the process variable, which basically means you can only work with a list of integers, 0, 10, -1. And that won't work for everyone. Not everybody is working in that space. So there's other ways to submit many jobs. And so here we're going to come back to our compare states example. Now suppose we have multiple states to analyze, not just Wisconsin data here. And so again, not numbered. So Q5 is not going to work for us. So instead, we're going to use our own variable instead of process, and we can choose what it is. So here I've replaced the pieces of the submit file that need to change or vary with $in file, so my own variable in all the correct places. And then I'm going to use the Q statement to, instead of generate a list of numbers, which is the default if you do QN, but to provide a list of names or values. So I technically have 4 options. We don't really recommend this last one because it sort of defeats the purpose of making our lives easier. And so I can generate a list of values through a pattern, so the wildcard here, through a list that I actually write into the submit file, or through a list that's contained in an external file, one item per line. And so there's a subtle difference sort of in the keyword you use here, depending on how you're generating the list, but it's all basically the same idea. This is functioning like a loop. I set my variable based on a list of values in some way. So pros and cons, matching, super easy in some sense, just a wildcard. We have found that the from syntax is kind of the most flexible and powerful. It's easy to swap in and out lists of values to make it easy to run tests. So this slide has all of that in detail that you can read later if you're really interested in this. A few extra kind of features of these functionalities. The from syntax, another reason we really like it is you can use combinations of input values. So you don't just have to have a list of single items, but you can actually have tuples or more. So in this example, if I made my job a little more complicated, I could do combinations of states and years, for example. If I put all the combinations into my list, it will generate all my jobs. The matching syntax has the ability to match only files and directories. I believe all of the options have the ability to submit multiple jobs per item in the list. So you could do 10 jobs per input file, for example. And those are indexed with the step variable instead of process or proc ID. Okay, so that takes us to about halfway. These are the basics. If there's any questions, I'll happy to take them now. Thank you to Jeff for highlighting the joy of cooking. When I was putting these slides together, I realized there were some more American than I realized.
So
I followed the cooking reference. This is way at the beginning regarding log files. There's a lot of interesting information that's in the logs that sort of shows like how a task, a job, a collection of jobs is running in sort of on real hardware rather than say running perf. Is there, I guess, in the Condor software suite, an existing tool that allows one to parse a automatically generated Condor log file, so that it's possible of, okay, I run a test of 10 jobs, and it just before I'm going to submit 10,000, I want to see, okay, how long do they more or less run? How much memory do they allocate, so I can tune my resource requests? So is there any existing parser for the log files that could make that sort of development and debugging, more efficient?
Yeah, thanks for that question, Matthew. If the Condor team wants to chime in the notes as well, I'll do a quick answer before I move on, and any additional questions, definitely throw them in the document and I'll try to get to them by the end as well. We'll actually look at some tools in a minute in the testing and troubleshooting section, where you can do like a kind of quick summary of job history. So that's possible. As far as I know, there's not an existing tool to parse the log files, but we talk about it all the time. So it's definitely something that people have done, or like code up themselves. But the Condor team would better be able to answer maybe in the document.
Super quick interjection there. For looking at this job event log that Christina's mentioned, the Python bindings have a class to do it, and which will be discussed, I believe, during a talk later this week when we talk about the Python bindings. There's a parser in C++. There is a parser available in Perl, and you can also specify that this job event log be written out in either XML or JSON format too. So, you know, then there's 10 trillion parsers all over the internet for those.
Yeah,
cool.
Thanks, Todd. All right.
Okay, any other question? I don't see anyone in the Google Doc. So.
Okay, I will carry on then. But yeah, as questions come up, if folks want to put them in the doc, I'll definitely try to keep an eye on that and come back to it at the end. Keep an eye on my time here. Okay, so that's we've covered so far is job submission. Hopefully, good sampling of what's possible in terms of how to submit jobs, ways to submit multiple jobs, that kind of thing. Definitely always something more to learn there, but hopefully that's a good starting point. So now we're going to dig into a bit more some of the behind the scenes pieces of Condor, starting with job matching and class add attributes. So I'm going to expand the diagram I had at the beginning of this talk, where we had the submit point and the execute points. I'm going to add this central manager role in the middle that is really doing the work, where before I just had the HTCondor image of matching jobs with computers. And how to do this, it needs information about the jobs and the computers involved. And Condor stores that information as in this class add format. The format is all of the attributes for a computer or a job are of the format attribute name and then some kind of value, which can be a Boolean, a number, a string, an expression. Everything that Condor is tracking is kind of stored in this format. So a job class add is generated from information in the submit file. So things like the executable, that's the command shown here, the log file, user log, and some components will get added automatically via however HTCondor has been configured. Similarly, a computer class add in Condor speak, often a machine, is generated via like information about the computer, sometimes whether or not like it has a GPU or its CPU speed, and how Condor is configured. And you can see that the list of attributes is pretty different between a job and a machine because they're sort of different entities. So what Condor is doing with this information is it has job class adds for submitted jobs and machine adds for machines in the pool. And it uses information from each of those to match jobs to machines, jobs to computers. Once that matching is done, the submit point and the execute points actually communicate directly. So that's great. One of the reasons we talk about this in this intro tutorial, because you don't necessarily need to know how all that's happening behind the scenes, is class adds can provide a lot of useful information about jobs to anyone who's using the system. Administrators, but even just a normal user who's submitting their work and trying to figure out what's going on. So to see the job ad for a particular job, you can use the long option, -L for Condor Q. So here's Condor Q again. That will print out, I recommend you only do this for one job, otherwise it's a lot of information. That will print out the class ad or job ad for a single job, and you can kind of see what attributes exist. Attributes that I use a lot when I'm looking at jobs or troubleshooting are the user log, the initial working directory, memory usage, remote host if the job is running, and just general identifying information like the cluster ID, proc ID, batch name. There's so many options, so definitely see the manual as well if you want to kind of see a list of what's possible. You can then, for a group of jobs selected either via your username or a cluster or something else, print out attributes of your choice using the auto format option. So shown here is -AF, and then list of attributes. So this is a really nice way to get a summary of information about jobs that are in the queue. So a little bit addresses some of this question of how to see, like, summarize what's happening over a group of jobs. And you can use attributes and operators, logical operators, to select jobs in the queue. So beyond the sort of standard username, cluster ID, job ID, you can also use this constraint option and then a logical expression in single quotes to select a subset of jobs. So this is a way to select only jobs that are running, for example. And I think we'll see an example of that later as well. Okay. One final Condor queue option, which would be useful if you are looking at more people's jobs than your own, is the -all flag. And then you can combine almost any and all of these flags to see the queue output you want, both in terms of selecting it and then displaying the information that you need. Okay. So mostly, I find most users, the main thing they need to know about class ad attributes for is to look at their jobs. But they also can be useful to look at computers. So Condor status lists all the machines in a pool in the same way that Condor queue lists all the jobs. And a lot of the options work in the same way. So by default, you'll see in this output, Condor status shows individual slots. If you want to group slots by the actual machine they're on, you can use this compact flag. And you can also use -L on a particular slot to get all the class information, just like you would for a job. And you can use -AF, auto format, and a list of attributes to display a set of attributes about a set of machines, just as you would attributes about a set of jobs. Okay, so that's a little bit about class ads. Lots to explore there if you want to kind of poke around in a queue and see what's available. Some of this information is helpful when we move into testing and troubleshooting because not everything is going to run smoothly. So I categorize problems with Condor jobs in sort of two classes. One is that something happens like inside the job with the executable. It has a bug, it can't run successfully, something like that. And then the second category is that jobs can go wrong from Condor's perspective. It can't start the job at all. It uses too much memory. It can't even start the executable. And those will be handled in a different way. So first, if your problem is the first class, using log, output, and error files are super helpful. That is a lot of your troubleshooting information, especially the error file, because that's what it's supposed to capture. Sometimes, though, that information doesn't come back, and then the log file can sometimes at least give you some idea of like where it ran, how long it ran, and that kind of thing. You can also look at past jobs if you want to kind of look at previous successes or failures using Condor history. Condor history, depending how it's configured, sort of records jobs up, previous jobs up to a certain amount. So if you have really old jobs, they probably won't be viewable through Condor history. But it works a lot like Condor queue. Condor queue is for current jobs. Condor history is the past jobs. So the same -L long flags, same auto format -AF flags work here as well. And one final option for figuring out what's happening inside a job as it runs is to use Condor SSH to job, if that's available on your system, where you can, this is assuming it's not like failing instantly, you know, but like a job is running and you kind of want to check on it. You can use Condor SSH to job, the job ID, and it will connect you to the job using SSH. You can sort of be a fly on the wall. Okay, so our second category of job problems where like Condor is not able to somehow run your job somehow for some reason, it will put the job on hold, which is an indication that there's something you need to do in order for it to even be able to run. A job that goes on hold is interrupted. If it was running, all progress is lost, but it stays in the queue in this held state, which you can see in the output below. You can view why a job went on hold, so just the held jobs, and why they're on hold by using the -hold flag, Condor Q. Here we are again. And it'll print out a job ID and when it was held and a hopefully informative message about what's wrong. And so the hold messages that are displayed here correspond to the common hold reasons listed on this slide. I would say this is based on our experience of running HTCondor at the Center for High Throughput Computing. But memory overuse, file path typos, those are big ones. Output files can't be returned because of quota, or there's something wrong with the person's executable, often a bash script, that it can't be executed. So, so when jobs go on hold, sometimes all that needs to be changed is an attribute of the job. So this is true of, say, the memory overuse. You could increase the memory request and try again. To do this, you can use the Condor QEdit command. You put in a specific job, the attribute, and the new value you want to set it to. So this allows you to modify the actual job add in the queue. And then Condor release will release a held job basically back to the idle state, and it will try to run again. Sometimes it's better just to remove and try again. So you can do that with Condor RM. If you know, you don't have to wait for Condor to put your jobs on hold. If you know there's a problem that you can fix, either fix the jobs in the queue or edit the executable, you can put jobs on hold and then release them if you like. So those are all kind of tools to manage held jobs. And so to revisit our diagram from the beginning of so the perfect job goes from idle to running to completed. But we also have this now held state where a job can be put on hold by Condor or Condor hold really at any point, idle or running. It can be released to run again using Condor release. And then at any point you can remove jobs, which is different than having them complete successfully, but still means that they leave the queue. Okay. All right, we're still doing good on time. All right. So that's troubleshooting information. And yeah, I just saw Jeff's comment. SSH to job, if it's available, is more important. Yeah, it really depends on the system you're in. So we can use Condor SSH to job on our local Condor pool, but it doesn't work when people's jobs are running, say, out in the open science grid, because often it's not configured that the site where the job is running will just allow someone, Condor to make that SSH connection. So that's a good point. It works best, I think, in like a local or very kind of shared context. Okay, so this next section is a grab bag of use cases and HTCondor features. You can run things interactively with Condor. This has the same caveats as Condor SSH job, actually, as was just mentioned, because that's what it's using behind the scenes. But you can do Condor submit, add this -I for interactive. flag, and it will basically go through all the normal steps of a job submission, except instead of transferring and running the executable, it will transfer and run you via SSH. So you're connected to the job via SSH, you get a shell session, and you can run commands interactively. So this is mostly useful for testing and troubleshooting, not for like production work, but can sometimes be handy in like figuring out exactly why something isn't working the way you expect, especially since most of the job environment is similar to what it will be in a normal submission. Self-checkpointing. So by default, a job that's interrupted on a Condor system, so it's running on an execute point, gets interrupted, evicted specifically, will lose all its progress and need to be, and if it goes back to idle, runs again, it'll start from the beginning. You can sort of implement your own self-checkpointing, which can be useful for jobs that are very long or running on opportunistic resources where the possibility of eviction is high. So this requires some work on the user's part in terms of having an executable that can save state to a checkpoint file and knows to resume from a checkpoint file if it exists. So that's on that side. And then the simplest way to do this is to change that when to transfer output option to on, exit, or evict. Then Condor will preserve or keep intermediate files, including the checkpoint files between job runs. So copying them back to the submit server and then copying them back out to a new execute point. There's also a new option. I think Todd Miller can put notes in the Google Doc if needed, called checkpoint exit code, where you can sort of schedule how long something runs. And if it exits with a particular code, it doesn't leave the queue, but it will keep running. So it's a way to kind of more schedule when things are going to checkpoint, exit, and run again. A little less random than opportunistic resources. So up to this point, we've kind of assumed that every submit file is running a job in Condor's default vanilla universe. And that works for, I would say, a large percentage of what most people need to run. It's just kind of a standard environment, but Condor does have other universes for running specialized job types. Probably the most notable one that we use in the CHTC is Docker. So you can say universe equals Docker and provide the name of a Docker image, and Condor will basically behind the scenes pull a container from Docker Hub, start it, and run the job inside by mounting the normal execution directory into the container. And otherwise it proceeds like a normal Condor job. So that's that. And then there's various other universes for Java, standard. Condor team can correct me if my statement here is correct, because I don't understand it well, which is no longer supported in newer versions of Condor. Local universe will run jobs on the submit point instead of the execute point. There's a VM universe and parallel universe for multi-machine jobs. You don't need parallel universe to run multi-threaded or multi-core code on one server, one computer. There you just need to request multiple CPUs. As long as there's a computer machine in the pool that can meet that requirement, that's all that's needed. You don't need parallel universe. Somewhat related, if there are GPUs available in your system, those can be accessed with request GPUs. Okay, I'm not going to go into a ton of detail on these slides. This is like more, you can refer to this later. Also, talk to your admin before you implement some of these, just to make sure it's the right fit for what you want to do and isn't going to cause any problems. So normally you submit the job and then Condor just, you know, does its thing. It decides when jobs are going to run and it tries to run them, and sometimes it puts them on hold. You can further interfere with what happens by using some options that will customize and automate job management even after you've submitted. So for example, if you want to retry jobs, because in general your jobs work, but if they land on a bad node, they might fail, there's an option called max retries, which will leave a job in the queue if it fails up to, in this case, 5 times, and try again. There's also an option that will basically throttle the amount of jobs submitted to the queue at once. So this is useful. Your administrator won't be happy if you try to submit like 80,000 jobs at once, but a few thousand might be okay. And so max idle, you can set sort of the maximum that are submitted at any one time and that are kept idle. And this won't limit the amount that you have running, which is really nice. Okay, so in the following slides, we're going to use more job attributes to control what's happening. And these are some of the ones you'll see. This is a current time, entered current status. So that's the last time the job went from, say, idle to running, or running to held, or something like that. Jobs exit code, hold reason code, job status. So those are all numbers that kind of indicate the status of a job and how many times it started. And so these can be used to automatically hold jobs based on some kind of criteria. So the example we're using here has been running for longer than we like. So job status and then time limit. You can automatically release jobs. Again, a lot of these conditions are extremely important. If you just sort of implement this without consulting your administrator, you can do a lot of damage. So please talk to them. So this will automatically release held jobs. Again, should be done carefully because jobs often go on hold for a reason. And you can automatically remove jobs using a periodic remove. So these are all statements you can put in the submit file to kind of automate what happens to jobs after they're submitted as needed. This is especially fancy. This is using job attributes to adjust a memory request as a job runs multiple times. Definitely be cautious with this. This is really only if there's a lot of variability in the kind of work you're submitting that can't be predicted, especially. And finally, the last kind of automation, I think probably the most important, is that you want to submit jobs in a particular order with dependencies. And the solution for that is writing a DAG, which is the next talk from Lauren. So stay tuned for that particular set of automation, and I will check the document for
Thank you, Christina.
questions.
Thank you for the transition, but I think that we have the time for a few questions. If somebody has a question to Christina. I don't see anything in the doc files.
Yeah, just comments in the doc.
Something.
So,
yes, no, there are a few things, so sorry. So there is a remark by Jeff saying that about Condor SSH2 job that you mentioned, that it is, if it's available, and so that this is an important restriction that's probably worth to.
Yeah. And Chris's comment about interactive jobs for scheduling across shared resources. Yeah, we've also, I think, put in some special sauce around interactive jobs to make it easy for people to access, say, our build nodes on our particular system. So yeah, if you can feel free to add questions. I'll try to check in later in the day as well. But yeah, I think that's all I had. There's the presentation slides, as I think most of you know, are on the workshop website, so check those out. That put in manual links where relevant. And yeah, I think that's it for me. So I'll go ahead and stop sharing.
Okay, thank you.